And welcome GT students. These series of 2 videos are instructional videos to help you out with problems 8 and 9 on your homework from last night. Please have your notebooks open and ready for this instructional composition. This question 8 deals with these 4 things color-coded. Look at my little picture above. The pictures will be the key to this situation, so always draw a picture when you start a situation. Let's do part A. Done. Part A, max height. In this picture, the max height occurs at this point up here. We're trying to find this distance. Is the time in the air the full time at this point? And the answer is, of course, no. To find the maximum height, we're looking only in the y direction. So my x and y table is really just a y table. Now, I know for a fact the acceleration is negative 9.81, not 0 like some people like to say. In addition, I'm trying to find the displacement. Now, what's really going to tootle your fancy, whatever that means, is the next two, VI and VF. Well, we know for a fact that at the top, it is not moving up and down. So I'm going to say the final velocity is 0. Notice, when I say final velocity, it does not mean right here. I'm looking at only this segment in the motion. So this is the final moment of that. So in order to figure out the initial velocity, we need to focus in and zoom right here in this little point. By zooming in, we can actually create a triangle based on the projectile. So we need to transform this into a triangle. Because this is the initial moment, we need to make an initial velocity triangle. In this triangle, I need to know the y initial velocity. Obviously, in this little triangle, the 75.2 is the initial velocity. This is the angle. This is going to be the sine term. Therefore, that triangle is the most important part. We're going to be using that constant initial velocity every single time we do this. I know that my acceleration is 9.81. I know my initial velocity is 75.2 sine 34.5, which is 42.6. The final velocity is 0. I'm trying to find d. What equation is that? VF squared equals VI squared plus 2AD. And you're going to solve that for the numbers involved. 0 equals 42.6 squared plus 2 times negative 9.81 times d. You can simply solve for d and come up with the correct answer of some value, which just happens to be 92.5 meters.
Woo!
And that is part A. Part B involves total time. Let's move that over here. For the total time, we can't use the same table as before because we're doing the overall motion. Now to find total time, we're going to make our x and y table. But if you look, this next one involves total as well. So I'll keep this table for both B and look at this. The table comes out of nowhere. Initial velocities for x and y, cosine and sine. Displacement for x we don't know, that's going to be part C. Displacement for y is 0 because it ends at the same height it starts off with. Time equals time. Well, there we go. That's velocity for you. So we're going to find the total time here. I'm going to use the y information because we know more about that. What equation shall I use? Well, silly rabbits. We know that d equals VIT plus 1/2 AT squared. Now hold your horses, Kimosabe. If you want to use your previous x and y table to the top here, you can find the time from here to here and multiply by 2 to get you the total time. But that's only true if it ends at the same height. So if it goes further, then this time will not be the same as that time. So just words of wisdom from good old Mr. Jockmans here. And we're back, apparently. I'm going to solve this for 0. I'm going to put numbers in here. Using the y information in this equation, you're going to do a little bit of hop, skip, and jump, and you'll get 8.68 seconds. Notice it's not a quadratic because d equals 0. But since we're here right now, let's just do part C together as well. We're going to find the total horizontal displacement. I'm going to add here that the time is 8.68, which you just found from the previous problem. Move that to this column. Well, I need to find the same thing before. I know the equation. d equals VIT plus 1/2 AT squared. Now, the reason why we all love x direction, besides the fact that it's the first one we learned, it's forward and backwards, is that the acceleration for x is 0. So plug in this number here and the time here, and you come up with the great old answer of 538 meters for x. And you and I are happy campers. Now, when it comes to part 4, though, the velocity at 1.5 seconds, here's where we really need to be careful and use a wonderful brain that we're given that's full of physics. 1.5 seconds. I know it's 8 point something seconds the entire thing. So the point is somewhere over here. Don't know exactly where. My normal tricks and tips may not work as well as before. The overall velocity is made up of two things, an x and a y velocity. So at this point, I need to find the Vx and Vy, because those two combined give me the overall. Now what you should ask yourself is, in this picture, we're looking at that interval. Is this the beginning or final point of the interval? Well, it's definitely final. So in my x and y tables, I'm trying to find the final velocity after 1.5 seconds. Here's our overall table. Now, one trick you can remember is, at any point in this arc, the x velocity does not change because of this fact right here. So this initial velocity is the same as the final velocity at any time. So I'm going to write underneath here, I already have an answer. Final velocity is this value, 62. Which comes out to be, but is that the same for the y? Is the y velocity always constant? Absolutely not. We're going to use this equation, we're going to find the final velocity at this time period. So the time period is going to be 1.5 seconds. The acceleration is going to be gravity. You can plug that in at your own leisure. And the initial velocity is this term right here. You got to find Vf. Do the math, you're going to find it to be, whoa, is it positive? Look at this point. Is it still moving upwards? Absolutely. So therefore, this has got to be positive. The math works. It just makes sense. We have a Vf for the x, we have a Vf for the y. We got to put them together and make a triangle. You know what to do, kiddies. Pythagorean theorem, do your value, get the velocity. Now, a quick thing you didn't have to do here, but you have to do in the next problem. Is it ask for the angle eventually? Well, with this new picture setup, you can definitely find it. And whoa, look at this. Slowly and surely, at this point, that really poopy looking triangle I drew is actually just this one put in there. And that, my wonderful students, is how we do number 8 in the hood. And we're back for number 9. Number 9 is pretty hardcore when you first look at it. But if we just take the lessons from the last video, including a lot of stuff about what to do at the point P, otherwise known as the 1.5 seconds from the last one, you're going to find out to be a lot easier. Take this picture up here. Your initial velocity at some angle going, and it drops down to 140 meters before where it starts. Range equation does not work. Symmetry does not work. What does work are x and y tables. First of all, we're going to find the time to point P. Point P is after 140 meters. I'm going to be making my x and y tables for everything up to point P. Since all these involve point P, my x and y table will always work for each one of these situations. That's how we check it out. And our x and y table is made. Once again, I use cosine for x, sine for y. That's normally true with projectiles. I got to find the time to point P. Well, which one has more information for the time for point P? In this case, it just happens to be y. Oh, geez, it's a quadratic though. There's nothing equal to 0. So I'm going to do d equals VIT plus 1/2 AT squared. I'm going to plug the numbers, and this is why you have pause functions in the movie player. You end up with a number, 14.27 seconds, and some negative t I really don't care about, just like Justin Bieber. That is going to be your time. Therefore, let's add the time in for x and y. We're going to have to find the range to P. Hold your horses about using the range equation to find the range here. Range just means dx. And in this case, we can't use the range equation because dy is never 0. Well, it's not 0 in this case. I'm sorry. We got to find dx. There's an equation. D equals VIT plus 1/2 AT squared. This is, of course, all 0. And when you do the math, this comes up to be 1142. It's that simple. Point C says find the x and y velocities at point P. So that's going to be the final velocities for this entire interval. So I'm going to add something new to my table. VF for x and VF for y. But if you're looking at my previous videos, which you are, YouTube, VF for x does not change. It's the same as VI. So I know here that Vx at point P is really just the initial velocity, which is 100 cosine 37. And a little bit of love and a little bit of math, you get 79.86. But look at point P. It's down and to the right. So our VF will be negative for that case for y. And when I do the math from this table, I'll do VF equals VI plus AT. Notice time is to point P, acceleration for y, VI for y. You get negative 80. We just solved part C, and the party continues. Next, we're going to find the velocity magnitude at point P. Magnitude can stand for two things. On NBC's Community, it stands for a very young man played by the actor who played Lee Jordan in Harry Potter, who's famous for going pop pop. But in physics, it actually stands for the amount and not direction. We're going to find the amount of the total velocity at point P. It's made up of Vx and Vy. Here's point P. I'm going to draw my two vectors in. Here is Vx. Here is Vy. And this is the overall hypotenuse. Here's my triangle. This is the final velocity we're going to try to find. This is the x. This is the y. We're going to use the Pythagorean theorem, and it comes up with around 113 meters per second. Now, some students are saying, hey, should that be negative or positive? My answer there is, first of all, I'm looking for the magnitude. Magnitude just means amount, not direction. But secondly, if there was to give you a direction, for example, part E, it can't be left or right, up or down. It's a combination. We can't use negatives and positives in terms of things at angles. That's why we use angles and bearings. Those are our ways of discussing direction outside of the magnitude. So when you see magnitude, you just want a number. You want a direction? That's the next part. Let's find this angle. Here's point P. This is the angle. That's next to point P. You could use inverse sine, inverse cosine, inverse tangent, and I expect you to do that in future problems. But right now, these two sides are pretty much equal. This has got to be 45 degrees. And with that, my wonderful students, you are now done. You should probably close this video, exit Facebook, do some homework, and say hi to your parents for me.